Hello everyone, is the Prophet Michael David aka Aries, and today we're going to go over my fourth Collatz solution explanation video, and today we're going to do with binary. So why should you care, or why should you be interested in it other than just curiosity? Is because I was watching that video and there's actually money. Some Japanese company put up almost $1 million for a Collatz solution, which I promise you I have. Then you're going to ask, then why don't you just do it yourself? Well, God won't let me. And even if you don't think that I'm a prophet, let me just put it another way. What's the point in being the richest or most famous person in a dying world like we're living in? It doesn't really make much sense. And then number three, I could have already been rich other ways. I'll do this all in a soon upcoming video, but today's all about Collatz, and the binary is fantastic, and I'll explain a little bit more. So probably almost everybody knows that the world runs on binary code. That's what code is ultimately in binary, zeros and ones. But what I found when I looked into it myself was that the Collatz conjecture, the binary actually in a visual way shows the number, how the numbers relate to themselves, like the magic numbers that I was talking about, and the other ones better than our actual base 10 number system does. So here we go. All right, that's my screenshot of my OG spreadsheet that shows the four different types of numbers that we're going to be talking about. The gold ones are what I call rail numbers, like third rail. Those are the ones that go down to one. And then the ones that feed into them are called magic numbers. And then the ones that feed into them are called progeny numbers. And then the ones that feed into them are called prophet numbers. And yeah, the prophet thing is both a little on the nose, but it is very descriptive of what they are. So now I'm going to go over them each individually. So, like I said, those gold numbers are rail numbers. They go all the way down to one and you insta win. But it's only half the numbers on the two up to the end line. And the reason for that is because I was thinking of the next numbers, which are called magic numbers. They have to 3x plus 1 up to those rail numbers, and then you go all the way down to 1. And so I realized that not all of those numbers were on the 3x plus 1, aka the 4 mod 6 line. Only half of them were. And that's what I've kept saying about how 4 is on the 3x plus 1 line because 4 minus 1 divided by 3 is 1. 3x plus 1, when you type in 1, equals 4. And for the same reason, 16, because 5 times 3 plus 1 is 16. But you can't 3x plus 1 up to 8, because 8 minus 1 is 7, and 7 divided by 3 isn't a whole number. So then I thought, what do all the real numbers look like in binary? As you can see, in binary, you begin to learn that those zeros in binary on the end of the number are just basically twos. And so the first one, 4, is 100 because it's just 1 with two twos, 1 times 2 times 2. And then 16 is just 1 with four twos, 1 times 2 times 2 times 2 times 2. And so you can see how why those all decay down to 1 when you hit those numbers. Divide by 2 takes off a 0. Divide by 2 takes off a 0 until it gets all the way down to 1. That's how all Collatz games end. So those are the magic numbers, that 3x plus 1 up into the rail numbers. Um, the only difference between the pinks and the reds are that the pinks have the next number called progeny numbers, but the reds don't have any progeny. Or they do, it's just not on the 4 mod 6 line. And just real quick to try to diffuse some confusion, the white numbers are the same thing. They're either pink or red. I just haven't gotten that far on my spreadsheet yet. So, what do magic numbers look like in binary? Do they look closely related like the real numbers did? Yeah, they do. They're awesome. As you can see, all the magic numbers are in binary are in the form of 101 and then 01 and then 01. They get progressively bigger by the 01, which looks real cool, and you can tell they're related. Um, but there's a very specific reason why it does that, which I will get to later. But for now, let's keep going down the rabbit hole. If the magic numbers go up to the real numbers and go down to one, then there has to be some numbers that decay down to the magic numbers so that it can go up to the real numbers. And they would be the magic numbers times two, and then times four, and then times six, and then times eight. And that's why I call them progeny numbers, because of the magic numbers just with extra twos attached to them. And then I noticed that they were also all on the 3x plus 1 line, or the 4 mod 6 line, except for odd numbers that were on the 3 mod 6 line themselves. I know kind of sounds complicated, but I'll explain it real quickly in one more way. So all odd numbers have to be either 1 mod 6, 3 mod 6, or 5 mod 6. Um, all of the 1 mod 6 numbers and the 5 mod 6 numbers, again, both lines that have all the primes and prime factors, do have progeny on the 4 mod 6 line. The one odd line, the 3 mod 6 line that does not have any primes on it, except for 3 itself, does not have any progeny on the 4 mod 6 line, aka the 3x plus 1 line. So that's the screenshot of the progeny. And again, one more time, the reason I use the same coloring convention that I normally use for the 1 mod 6 and the 5 mod 6 line. 5 mod 6 is always blue, like the sky, and the 1 mod 6 is always green, like the ground. And the reason why it only has the blue and green, again, because the red one, the 3 mod 6 line, doesn't have any progeny at all. They're only magic numbers. They don't have any progeny, at least on the 4 mod 6 line. But now let's see what they look like in binary. All right, so that's the first three progeny of just for the number five. But as you can see, it's basically the same number and you're just adding more twos. That's why you're adding more zeros to the end. So let's see what the first three progeny for 85 look like. Bigger starting 101 number, but same effect. So finally, let's look at the progeny of the third magic number, 341. Even bigger starting 1010 number, but same effect. So at that point, I had progeny that decayed down into magic numbers, which 3x plus 1 up to rail numbers, which won you the game. And the natural progression on that is that there have to be some odd numbers that 3x plus 1 up to the progeny, which go down, decay down to the magic numbers, which 3x plus 1 up to the rail numbers, which win the game. And so these are those numbers. These are those numbers, and they're called profit numbers. Again, it's kind of a joke, kind of not, because they're the first part in a process, and they're directly related to the magic numbers. And so here are the profit numbers for the magic numbers. All right, just like with the progeny, there's three slides for each magic number. So that's just the profit numbers for five. And if you look real closely, three is the only one that breaks the pattern just a bit, and that's just because three is weird. The beginning of the number line is kind of like the beginning of the universe. The rules were not the same. So those are the first three profit numbers for the magic number 85. And you can start to see how the pattern is building up, that you're getting a bunch, not a bunch, but a few ones at the start of the number, and then a bunch of zeros in the middle, and then that 101 at the end of the number. That 101 shows up again, and again, we're going to come into that really quickly, but we have one more set of profit numbers. So those are the first three profit numbers of the magic number 341. And as you can see, the pattern is a little bit different than the last one, and it has to be because they're different numbers. But overall, it's building up the same way with the ones at the beginning, and then it has a stretch of two ones on that one, right? But then it's building up that 101 pattern at the end. So, what is it especially about that 101 pattern that lends to the Collatz game? Because it kind of seems at this point that the game is just trying to turn all the ones into zeros. And that's exactly what the Collatz game is. That's exactly what it does. It's kind of like a sieve, but there's a randomized version to it each time. But again, here's why that 101 pattern comes up all the time. So you can add binary numbers just like regular base 10 numbers. You just got to remember that when you add them, 1 plus 1 equals 2, but that equals 0, carry the 1 in binary. And therefore, 1 plus 1 plus 1 equals 3, but equals 1, carry the 1 in binary. So that's all I did was add it up because 3x is a number multiplied by 3, or you can just add three of them together, is what I did. And as you can see, in binary, when you do that with any number that is 1, 0, 1, 0, 1, 0, 1 in that format, three of them to get added together turn into a number that has all ones. So then finally, when you just add 1 to that number in binary, remember it's the 3x plus 1 game, that number that is all ones, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry 1. That number turns into a number that has no ones except the one on the very end, the first digit. And that very large number with many zeros, is just the number one multiplied by a bunch of twos. And so it's a real number. And every time you divide that binary number with a one and a bunch of zeros, it loses a zero. Then you divide by two again, it loses a zero, it loses zero, it loses zero until it gets down to the number one, which is the end of all Collatz games. I did have more slides, but since this video is already over 13 minutes now, I think I'm going to wrap it up. I'm just going to show my algorithm one more time and then do a quick pitch, like elevator pitch, on why this thing is totally solved because of the two conditions that I've described in the last two Collatz videos. Okay, as we talked about in my last video, that was actually brought up by the gentleman in the Quora screenshot that I had, that there's really two factors of how to actually solve the Collatz conjecture, or two things you need to do. You need to show that the Collatz game can't get caught in any loop except for the 4-2-1 loop, and that the game can't go to infinity. That, again, is my algorithm, which proves both if you pay really close attention, but what it does really well is it shows that it can't get caught in any loop except for that 4-2-1 loop. It can only get caught in three. The 6 mod 6 loop down at the corner into a 4-2-5 loop or a 4-2-1 loop. And as I described in the last video, it can't get caught in the 6 mod 6 loop because it eventually hits OG6, which is 6, divided by 2 is 3, goes to the 3 mod 6. and it can't get caught in the 425 because it eventually gets to OG5, and then 5 times 3 plus 1 is 16, which goes to the 4 mod 6, and that's a rail number, and that ends the game. But the binary argument, and what I've just displayed to you guys in this video, is very supportive as well. Why can't it go to infinity? Because eventually it's going to have infinitely number times. You're going to hit those numbers with a lot of 1 0 1 0 1 zeros at the end, and you know that when you 3x plus 1 that, you're going to get a number with a lot of 2's, and it's going to go way, way down. And so there's this constant fight between up and down, where the only time that it ever goes up is if you 3x plus 1 and it only has 1 2. The rest of the time it's going down. That's why a lot of games end very, very quickly. But each time that you 3x plus 1 a number, it's like it takes a number on the 1 mod 6 line or the 5 mod 6 line, the line with all the primes and all the factors of the primes, but no 2's, and it magically transforms into a number on the 4 mod 6 line that could have a lot of 2's. And so it's just going to keep doing that and recycling out the 1's and turning them into 0's until it hits, eventually, it will hit a prophetic profit number, which will send 3x plus 1 up to a progeny, which will decay down to a magic number, which will send it back up 3x plus 1 to a rail number, which will go down to 1. It has to. It's inevitable. It's math. All right, in that light, I'm going to sign off. Feel free to use my work to write your paper to get your $1 million from that Japanese company. You should give half to me. That's what God wants, because I'm going to need it to help people and everything. But free will, what's mine is yours. That's kind of how this profit game goes. As always, rule number 1, do not touch other people without their consent, aka do not hurt each other. And rule number 2, it's all about honesty. Lies are ticked down, aka try not to lie. All right, I'll talk to you later.